Hi, I'm Brandon McKenzie, and in this video we'll be contrasting converging and diverging systems. First, we'll do a brief review of each of those systems, and then we'll explore situations where one system is preferred over another. Let's jump into it. First, we'll review converging systems. Recall that converging systems focus or converge light as it passes through the system. Two classic examples to look at would be a converging lens and a converging mirror. You can see in both of these situations, the parallel rays of light get focused towards the focal point. And now because these rays of light are focused towards the focal point, we can say that the focal length will be positive. In addition, converging systems can form real or virtual images, and it's all dependent on the placement of the object relative to the focal point. Let's take a quick look at this. Notice when the object distance is greater than the focal length, the image formed will be real and inverted. In our second example, the object distance is less than the focal point. Therefore, the image that will be formed will be virtual. Now, let's move on to diverging systems. Recall that diverging systems causes light to diverge or spread out as it passes through either a lens or reflects off a mirror. Notice that in both the diverging lens and the diverging mirrors, the rays of light spread out away from the focal point. Thus, we can also say that diverging systems have a negative focal length. Now again, this is a key difference for converging and diverging systems. Converging systems have positive focal lengths and therefore direct light towards the focal point, while diverging systems have negative focal lengths because the rays of light move away from the focal point. Finally, recall that diverging systems will always produce virtual images. In other words, these images will always be formed by the backtracing of diverging rays. Notice that in both examples, the image is formed at the intersection of at least one traced back ray. Now that both system types have been reviewed, let's do a direct comparison. Converging systems focus light, diverging systems spread out light. Converging systems will have a positive focal length, while a diverging system will have a negative focal length. And although converging systems can produce both real or virtual images, a diverging system can only produce virtual images. Let's try out a question. In this question, we are told about myopia, or nearsightedness. It results in the inability to view objects at a far distance. Think about that. That may sound really familiar. I myself am myopic. And I know to solve this issue, I need glasses or contact lenses. So what this question is really asking us is, for someone who is nearsighted, what kind of lens will be used to treat this individual? Now we are told some additional information. For instance, that the cause of this condition is the convergence of the light rays before they reach the retina. And for a quick ophthalmology anatomy lesson, here's the eyeball. We have our lens here, and the very back of the eye, that's where the retina is. Now, in an ideal situation, we want our parallel rays of light to impact and pass through the converging lens in front of the eye and be focused to the right degree to get the image to form right on the retina. Now that isn't always the case, and this definitely isn't the case for our individual here. So what's more likely to happen with our myopic individual is that these parallel rays of light will become over-focused, and therefore the image will form before the retina. And because essentially this issue of myopia is caused by the over-focusing of light, we can treat it by spreading light out. In other words, we will need a diverging lens. So let's see how the ray diagram will look with the addition of a diverging lens. Here we have the parallel rays of light being spread out by the additional diverging lens. It will then be focused by the eye's native converging lens. And if we get the prescription just right, that would result in the image forming directly on the retina, which would give our individual very clear vision. Now the next question asks us, what is the power of this lens? And recall the lens that we just determined was a diverging lens. Now I want you to focus on that word power, and you might even recall P equals 1 over F. But we actually don't need the formula here. Instead, the definition will be more helpful. Power is a measure of a lens's ability to focus light, and that's the key term there, focus. Our lens in the previous question was not focusing light. In fact, it was diverging light. Therefore, our power will be negative. So this means that lenses with positive power focus light, while lenses with negative power diverge light. Now at this point, you've seen just about everything you need to know to understand optical systems. So be sure to practice and review as needed in order to master this topic.